number 2, we are asked to discuss and trace the curve whose equation is y squared is equal to x squared plus 12x plus 36 over x to the fourth plus 4x cubed minus 12x squared minus 32x plus 64. So as you can see here, this is a curve of type 4 since we have here y squared is equal to a polynomial in x over a polynomial in x. The first thing that we are going to do is to find the factors of the numerator and the denominator. So for the numerator, we have here x squared plus 12x plus 36. Since the constant here is 36, we find the value of the factors of 36 that if added would give us 12. So that would be 6 because 6 times 6 is 36 and 6 plus 6 is positive 12. So we have here x plus 6 and x plus 6. For the denominator, since we have here degree 4, so we cannot make use of the calculator to solve for the roots. So we look for the factors of the constant. Since we have here 64, so that would be divisible by 2, divisible by 4, 8, 16, 32. Now, so we start with the 2. So what we are going to do is we have to apply the synthetic division. So for the coefficient of x to the fourth, that be 1 and x cubed, so 4, and for x squared, that's negative 12, and for x, that's negative 32, and we have the constant of 64. So we bring down 1 here, we multiply 2 times 1, so that is 2, so 4 plus 2 is 6, 2 times 6, that's 12, negative 12 and positive 12, that is 0. So 2 times 0 is 0. So negative 32 plus 0, so that's negative 32. 2 times negative 32 is negative 64. And 64 minus 64, that's 0. Since we do not have remainder here, meaning the positive 2 is a factor. So that would be x minus 2. So we just change the sign because this means that x is equal to 2. So if we are going to equate this to 0, so that would be x minus 2 is equal to 0. So the factor is x minus 2. So since we have here x to the fourth divided by x, so the first term here is x cubed. That would be 1 x cubed plus 6 x squared plus 0x minus 32. Now we solve for the factor of this expression. So we make use of the mode equation, that's 5 and 4. So we have here 1, for x squared that's 6, for x that's 0, and for constant it's negative 32. So the factors are 2 and negative 4. It only gave us two factors, 2 and negative 4. So x is equal to 2 and x is equal to negative 4. So this one is x minus 2, while this one is x plus 4. So since this is cube, it means that it has 3 factors. So one of these value is repeating. Now, if we are going to repeat this, let's say we have 2 of these factors. So that's negative 2 times negative 2. It's positive 4 times 4. That's only 16. But if we have 2 factors for x plus 4, so that would be 4 times 4, 16, times negative 2, that's negative 32. So this is what we are looking for. So meaning our final factor is x minus 2, another x minus 2 here, so that would be squared, and we have x plus 4 squared. So simplifying this, we have for the numerator, that's x plus 6 squared, because we have two factors for x plus 6. And for the denominator, we have here x minus 2 squared and x plus 4 squared. It's time for us now to determine the signs for this. So for the numerator, we have x plus 6 and x plus 6. And I will make use of the green marker for the factor of the numerator. That would be x plus 6 multiplied by x plus 6. While for the denominator, we have the x minus 2, we have x plus 4, and x plus 4. Now, if we are going to multiply this value, then that would give us the denominator. For simplification, we just delete this and we change this to numerator. Going back to our equation, so we have here y squared is equal to our numerator over denominator. So in here, we write y squared, which is y squared is equal to the numerator divided by the denominator. And if we are going to take the square root of y squared, that would give us the value of y. The next thing that we are going to do is, of course, to determine where this value would be 0. So for this, that would be on negative 6, this is in positive 2, and this is in negative 4. So we have here negative 6 and positive 2. So the x plus 6 would be 0 at x is equal to negative 6, so that would be 0, positive on the right, and negative on the left. So the same with this. Now for the numerator, we multiply these two factors here. That would be negative times negative, so it's positive. 0 times 0, that's 0. And this is positive, positive, and positive. So for the first factor in the denominator, we have the x minus 2, so that would be 0 at x is equal to 2, so positive on the right and negative on the left. So the same with this, positive on the right and negative on the left. For x plus 4, that would be 0 at x is equal to negative 4, positive on the right and negative on the left. So 0 here, positive on the right and negative on the left. So for the denominator, we just multiply these 4 factors here in order for us to determine the sign of the denominator. So we have negative, 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 and negative. So that would give us positive. So the same with this, that's positive. This one is 0. So negative, negative, times positive is positive. We have 0 multiplied by 0, positive, positive, so it's 0. And we have here positive. For the value of the y squared, you just have your numerator divided by the denominator. So that's positive divided by positive, so it's positive. 0 divided by positive, so that's 0. Positive divided positive is positive, and we have positive divided 0, so that's infinity. Positive divided positive is positive. Positive divided by 0 is infinity. Positive divided positive is positive. Now, we take the square root of this y squared for us to determine the value of y. So for positive, so that would give us plus and minus. For this, that's 0. And we have plus and minus here. And we have infinity. This is plus and minus. This is infinity. And we have plus and minus. So this only means that we have our x-intercept, which is 0. So located at x is equal to 6. And we also have a vertical asymptote located at x is equal to negative 4 and x is equal to positive 2. While for this region, from negative infinity to negative 6, negative 6 to negative 4, negative 4 to 2, and 2 to positive infinity, that's plus and minus. So we have the graph above and below. Okay, so let's start with our asymptotes. For the asymptotes, we already know the location of the vertical asymptotes, that is x is equal to negative 4 and x is equal to positive 2. For our horizontal asymptote, we divide everything by the highest exponent, so that's x raised to 4. So for the numerator, we have here x squared divided x, so that's 1 over x squared. So for this, we have 12 over x cubed, and for this you have 36 over x to the fourth. So x to the fourth divided x to the fourth is 1, and we have here 4 over x minus 12x squared, and we have minus 32x over x cubed, and we have here 64 over x to the fourth. So we now evaluate the limit as x approaches infinity. So we remember that if we are going to divide a number with infinity, or a very very large number, our answer is approaching 0. So this only means that if we have the expression x at the denominator, that would be 0. So it will give us 0 over 1. So our y squared is equal to 0, and taking the square root, so y is equal to 0. This is now the equation of our horizontal asymptotes. Now it is time for us to sketch the graph. So we have the x-intercept at x is equal to negative 6. So 1, 2, 3, 4, 5, 6. So that's negative 6. So we have x-intercept here. We have the vertical asymptote at x is equal to negative 4. So the vertical asymptote here has the equation of x is equal to negative 4. Another vertical asymptote at x is equal to positive 2. The equation is x is equal to 2. Next thing that we are going to do is, of course, to test for the symmetry. So as we can see here, our equation is y squared. So if we are going to change the y into negative y, our equation would be unchanged. So for the symmetry, this function is symmetrical with respect to x-axis. If we are going to change the x to negative x, so our equation will change since we have here odd exponents. So this would be negative. So this only means that no symmetry with respect to the y-axis. And simultaneously, if we are going to change the y and the x, so our equation would change on the right side. So meaning there is no symmetry with respect to the origin. For the symmetry, So since this is symmetrical with respect to the x-axis, so we are expecting that whatever our graph above the x-axis, that is also our graph below the x-axis. For the horizontal asymptote, since our y is equal to 0 is the horizontal asymptote, so this only means that the x-axis is the horizontal asymptote. Since we have the intersection of the x-axis and our x-intercepts at x is equal to -6, meaning at this point, our graph would cross here at -6, 0. For the y-intercept, what we are going to do is to let x is equal to 0. So every x here would be 0, so that would give us 36 over 64. So y squared is equal to 36 over 64. So computing for the value of 36 over 64, we take the square root of that. So we have the square root of 36 over 64. That would give us 3/4 or equal to 0.75. So that would give us our y-intercept at, of course, plus and minus 0.75. So the y-intercept would be right here at 0.75. The same with this, we have at -0.75. Okay. Now if we are going to sketch the graph for this, so we have our graph closer to our vertical axis here, since we have plus and minus. So that would be getting closer to the vertical axis. While for this, so that would cross here at our x-intercepts and the horizontal asymptotes, but that would go back closer to our horizontal asymptotes. So the same with the lower region, we have here closer to the vertical asymptotes and again closer to the horizontal asymptotes. So for the regions between -6 and -4, so we have plus and minus, but in this case our graph should not pass through our horizontal asymptote, so it only getting closer to the vertical asymptote at x is equal to -4, and that would go back to the y-intercept, and again closer to the vertical asymptote at x is equal to 2. So since this is symmetrical with respect to the horizontal axis, so our graph below should look like what is our graph above the x-axis. So for the regions +2 to the +infinity, that's plus and minus, so that is closer to the vertical asymptote, and again in here that would be closer to the horizontal asymptote. Since this is symmetrical with respect to the x-axis, so we're expecting the same graph at the bottom. Let us now discuss our curve. So since we already determined the symmetry, the intercepts, and the asymptotes, so we just talk about the domain. So for the domain, we have any value of x such that x is the element of the set from the -infinity up to -4, not included of course the -4 because this is our vertical asymptotes, union of the set from -4 up to +2, not included the +2 since this is a vertical asymptote, union of the two to the positive infinity. While for our range, as you can see here, we have the graph from 0 to the positive infinity and from 0 to the negative infinity. So we have our range is y, such that y is an element of real number. For the scope, we have our graph above and below the x-axis for the same region. So that would be below and above x-axis for the same range. So we have x such that x is the element of the set from the negative infinity up to negative 6, union of the set from negative 6 to negative 4, union of the set from negative 4 to positive 2, union of the set from the positive 2 to the positive infinity. For the discontinuity, we only have two values where our function is discontinuous at x is equal to negative 4 and x is equal to 2. So that will give us any x such that x is not equal to negative 4 and positive 2.